Welcome to this channel, and today we are going to discuss some matrix operations. We are going to use matrix to solve these simultaneous equations. We have three equations to three unknowns, and at the end of the solution we are going to show tools that are used in the industry to solve this type of matrices. And if you see the coefficients here, there's 1, minus 2, minus 3, 2, 1 and 1, 1, 3 and minus 2 for the x's, the y's and the z's. So we are going to pull, I'm going to pull some matrices from Text Studio and better formatting, so we can base our calculation on that. What are these matrices? These are all, the first one is the coefficients of x, y and z, and for dx we replaced the column of x with the right side vector, and to calculate this we are going to repeat the first two columns on each of these matrices. So 1, 2, 1 and minus 2, 1 and 3, and then we just multiply. When it goes down it is plus, when it goes up it is minus. So you go ahead and calculate. Okay, so for delta, the determinant here, you can say 1 times minus 2 is minus 2. Minus 2 times 1 is equal another minus 2, and minus 3 times 2 times 3 is minus 18, and then minus 3 is plus 3. Okay, and then minus 3 times 1 is equal to minus 3, and then minus 2 times minus 2 is, that makes it minus plus, and then we have the minus sign, that means minus 8. So we go ahead and I start with all the negative ones, so minus 22 here, and then minus 25, minus 33, and plus 3 is minus 30. So the determinant here is minus 30. So to find x, y and z, we have to calculate dx, determinant of x, determinant of y and determinant of z, and divide them by our determinant we just found. So we go ahead and do the same type of operations here. So we repeat the two columns, minus 1, 6, 13, and minus 2, 1 and 3. For the x, we see that we replaced the column of x with the right column, the right vector, minus 1, 6 and 13, and we do exactly the same thing we did on the first one. So we get for the first value is minus 1 times minus 2 is 2, and then we go ahead and keep calculating, and we get minus 26, and then minus 54 looks like. Yeah, go ahead, and minus makes it plus here, that's 39, and then minus makes it plus 3, and the minus makes it minus 24. Go ahead, we do the same calculations here. We have minus 26 and minus 24, that's minus 50, minus 50 and minus 54, that's minus 104. Okay, minus 104 plus 3 is minus 101, minus 101 plus 2 is minus 99, minus 99 plus 39 is minus 60. So we get delta x is equal to minus 60. So x is equal to minus 60 over minus 30. That makes it 2. Okay. And for the value of the determinant of y, we do the same thing here. You can notice that the column of y was replaced with minus 1, 6, and 13. And then we repeat 1 to 1 and minus 1, 6, and 13. And then whatever goes down is positive. It says, there you go. That will be positive here. And the other one, when it goes up here, will be negative, right? So we go ahead and you can say that the determinant for y will be minus 12, minus 1, minus looks like 78, 26 times 3. Yeah. And we go the other way, minus minus plus 18. There you go. And then minus 13. And then minus 4. There you go. Go ahead to do the same operations here. Minus 12, minus 13, minus 13, and minus 13, minus 26, and minus 4, minus 30, minus 30, and minus 78, minus 108, minus 108, minus 100, and minus 90. So that makes it minus 90. So we say that dy is equal to minus 90. Y is equal to minus 90 over minus 30 is equal to 3. There you go. So we found x is equal to 2, y is equal to 3. Remember, when we use advanced matrix calculation, we can use cofactors. But since this is just one sample here, we just limit ourselves to this type of calculations. So we repeat the same thing here, and what do we get? We get 13 minus 12 minus 6 minus minus plus 1 minus 18 and minus minus plus 52. 26 times 2. Alright, so if we calculate this one, we end up getting minus 30 and minus 12 minus 6 minus 18 minus 36 minus 35 minus 25 minus 22 and plus 52, it is plus 30, right? So dz, the determinant of z, will be 30. Okay. So we get 30. Now we are going to use some tools that are used in the industry to calculate matrices. We are going to start with Octave. Octave, if you use MATLAB, is the same as Octave. Octave is the free version actually. It does the same thing with MATLAB, so we are going to just launch Octave from this Red Hat box here, and I'm going to force the GUI version here, and if I open Octave, so we have Octave. It is the same as MATLAB, they are compatible. So if you want to practice MATLAB, you don't have the money, just download free Octave and do your practice. And when it comes to matrix calculation, MATLAB is one of the champions, and it is unfair to do some matrix calculation without talking about MATLAB here or Octave. So we are going to put the vector, this is the right side of our values, so we call it B, so -1, 6 and 13, and then this is our vector here. And now the matrix is like our determinant we calculated earlier, we call it A, and we are just going to put in the values. Remember, we separated the columns here by a semicolon, and we just type the value separated by the space, and semicolon is making it like the next row, and to 1 1, and then so forth. So we have our determinant here, our matrix. There you go. There it is. Now all we have to do is to say A, but B here is equal to boom, and we get all the results. This is what we found. X is equal to 2, Y is equal to 3, and Z is -1. Another tool used is R. So I'm going to launch R Studio from the same box here. So from R Studio is another powerful tool for number crunching. So when it comes to matrices and vectors, R is another tool that is really very powerful. So for R we just write the same thing, but here the notation is a little different. A less than, and then minus matrix, and then C, and then we just put the matrix. This time we put all the numbers together, separated by comma, and then we specify the number of rows, and to tell him, hey, I just need 3 rows on this with these numbers, and then do it by row. And then we go to the vector, which is on the right side. You see, this is our matrix, and then we get the other one also as a matrix on the right side, and the 3 values. You can see this 1, okay, -1, 6 and 13, as we've seen before. So we have these 2, and now we have to just tell R to solve these 2, right? So we have the 2 matrices, everyone has a matrix. So we say solve the first matrix A, B, and then it splits the results. So we get X is equal to 2, Y is equal to 3, and Z equal to -1. And the third tool I'm going to introduce you is Python. Python is used also for number crunching, the data science today. So if you have been using Python, you know this is Spyder actually, by the way. So we import NumPy as NP, and we just enter our matrix. Say this here. So we get A, and you see the notation here is a little different. So libraries, Python libraries are very powerful as well, and once we enter the matrix here, we call it A, and again the vector is x here. The right side is -1, 6, and 13. And now we have to use libraries from NumPy to tell him to solve this for us. So we can call the result as a solution. SOL is equal to np the NumPy dot linear algebra lin alg dot inverse a and then dot x, and that's the notation. And then if we ask him now to print the result, print sol, we will get our three values, our x, y, and z. So this is how to solve it using Python. Thank you for watching, and see you in the next video.